let's save this and let's bounce over to the world class. Right? Instead of manually defining where the balls start, let's go ahead and also add a random value to this, so we can see if it's not about their starting position. So I'm going to say that the position will be between 0 and width for my starting x, random 0 and height for starting y. Right, and it looks like we have some close, this is close to working, right? We have some objects that are clumping together, and it seems like these guys are bouncing against each other, but they're really far away from each other. All right, so let's go back to our ball class and see what we have here. Here's the distance, other rad plus rad. Okay, so what we're going to do is we're going to add in a kind of workaround so that we don't have to get into the math of actual collisions, so that it's a little bit easier. But this will help us prevent our objects from clumping together. So what we're going to do is we're going to test to see if the absolute value of x speed is less than the radius. If that's the case, then what we're going to do is move the position of the object a little bit by redefining the x position minus equals x speed over the absolute value of x speed times radius, right? So what this is going to do is, if the objects are clumped, move them and move the current one in the opposite direction, the amount of the radius, right? So move it away. And this is how we make sure that the direction is correct. All right, and we'll do the same thing for y. So I'm going to copy and paste. The absolute value of y speed is less than the radius. We'll take y pause, y speed, y speed. Okay, so it seems like they're clumping less, but things are getting a little wacky in terms of how fast they're moving, etc. So I'm going to reduce the speed here, and I'm going to reduce the size a little bit so we can see what happens a little bit more clearly. All right, so it seems as though our distance method is a little bit extended. They're not actually touching when they're bouncing. So let's double check our distance calculation. The distance is the square root of pow other.x minus x pause to the 2 plus pow other y pause minus y pause raised to the second power. Let's go ahead and encapsulate this within parentheses to make sure that that's working right. Other rad plus rad. Okay. Let's double check that it's not radius over 2. There we go. So when I used my ellipse mode, it changed how the circle is being defined. So the radius over 2, I guess it was actually being defined by a diameter. So let's double check the ellipse mode. I typed in center. This should say radius. And then our equation up here would have worked without the divide by 2. Okay. There we go. Much better. All right, and now our objects are just a little bit big. All right, so now we have objects that are bouncing off each other based on looking into their context, which is the world, finding the proximity to their neighbors, and if they reach a certain threshold, they're going to bounce, right? So we now have this working successfully, and let's go ahead and add in a color indicator to kind of show us a little bit more specifically how many times each one of them has bounced or collided with a neighbor, right? So we have 20 of these balls bouncing around within the context of the world. And let's just go ahead and use the visualization capabilities of processing to kind of accentuate what's actually happening. So I'm going to close this window. I'm going to save this. We're going to go back down to the collide method. And if this condition is met here, we're going to do one more thing, which is to make sure that we count the number of times this ball has collided. Right? In order to do so, we need a property that goes along with this class. So we go up to the top, and this is going to be define a counter variable. Right? So this will be collision count. So int c count equals 0. Right? So whenever the object is created, it will start with a c count of 0. And then down here, whenever we have met this condition, so we're inside this if statement, we're going to say c count plus plus. So I'll add 1. Right? What that means is that we can go down here and let's say take our RGB, our blue value, and say that each time that this count goes up, we're going to use it. So we'll say 10 times C count. So as they have more collisions, they'll get more blue. All right, so they start off green, they start colliding, and they start becoming blue. All right, and this will be even more clear if we increase the number of balls inside the world. So I'm going to take, actually I don't like the green to blue setup, so I'm going to move this over to the red. So 10 times C count and put this back to 255. So they start blue and they should start getting more magenta or purple. There we go. All right. So let's go ahead and increase the number of balls that we have to 40. And we can see this behavior a lot more clearly. All right. So all of the ones that are pink are colliding much more frequently than the other ones that are blue. All right, so let's take a couple of questions before we look at the next exercise. So if you have any questions, go ahead and drop them in the question window. Okay, so another question is, what else can you do with the collision to change what we're seeing in the display window? Well, our C count is one variable that's storing how many times we've collided with another ball within the world. So we can continue to use that specific variable for any of the elements that we're using within the render method. So we could go down here and say, okay, well, every time that we collide, we're going to change the radius, right? So maybe the radius minus C count defines the size of the object also. So each time they, well, this is interesting. They're getting bigger once they go past 0. So rad minus C count. So we could take the minimum between 0 and rad minus C count, or let's say 2. So let's take the minimum between either 2 or the simple expression of the initial radius minus the C count. Sorry, it should be max. Take the larger of the 2. There we go. So we'll get down to 2, and that will be it. They don't get any smaller. So as they collide, they lose some steam and they get smaller. All right, that's a great question. All right, so let's move on to the next exercise.